Hello, wonderful Anton. Cosmology solved. This is a speech resolving all of cosmology. The universe is not expanding into space, it is selecting more space-time history. Copenhagen quantum collapse cannot give us a live cat now without also giving us a live cat before. The real question is not whether the cat is alive or dead, but why its entire past arrives perfectly matched. Schrödinger's cat is not your ordinary cat paradox. This cat in the box arrives after measurement, loaded with random siblings, random DNA, random scars, and a mother cat who apparently enters reality at the same time as the measurement. Low mileage, one owner, completely impossible ancestry, cat-parent paradox. The cat-parent paradox. The expansion of the universe is not best understood as matter flying outward through an empty container, but as the growth of the metric relations that define cosmic distance, horizon, cooling, and the record. In standard cosmology, the scale factor increases, photons redshift, the cosmic microwave background cools, matter dilutes, and late-time acceleration appears as dark energy. In the Born-Hillborn interpretation, the same expansion is the macroscopic signature of selected spacetime history. Quantum possibility is weighted by spacetime expectations, including future observation constraints. The universe expands because the selected history requires increasing relational capacity for records, entropy, stars, black holes, observers, memory, and future consistent meaning. The Big Bang is therefore not a bomb exploding into space, but the earliest low entropy boundary of the selected cosmic record. Inflation becomes rapid holographic registration, the early smoothing of our spacetime sheet required by the later coherent universe. Dark energy becomes future-weighted expectation, pressure-read geometry by general relativity. Dark matter becomes, at least in part, unseen memory geometry, the gravitational shadow of history that luminous matter alone does not display. Black holes become memory stars, as I call them, or ledger stars, horizon-bound accounting surfaces where selected history and comparative alternatives are compressed. The Born-Hillborn thesis is that cosmology is not the study of debris after an explosion, but the study of how quantum possibility, space-time structure, and expectations select a universe large enough to remember itself. The universe is not expanding as matter flying through emptiness. In standard language, expansion is the growth of the cosmic scale factor. The metric relation between unbound regions changes, photons redshift, matter dilutes, radiation cools, and the late-time acceleration appears as dark energy. Born-Hillborn accepts these phenomena, but reinterprets their ontology. The scale factor is the macroscopic signature of selected history registration. The universe expands because the selected cosmic history requires increasing relational space-time capacity for records, for entropy, stars, black holes, observers, memory, and future consistent expectations. The Big Bang is not a material explosion from nothing. It is the low entropy boundary of the selected record. Inflation is not merely an arbitrary early scalar episode. It is the rapid holographic smoothing of the selected spacetime sheet. The CMD is not dead afterglow. It is the first visible memory page of the universe. Dark energy is not merely mysterious repulsive substance. It is the future-weighted expectation, pressure appearing geometrically as accelerated expansion. The Hubble tension is not necessarily an error. It may be the signature of treating a future-weighted selected history as if it were a dead past-driven fluid. Dark matter is not merely invisible stuff. It may be unseen history selecting geometry. Stars are local history engines. The sun creates irreversible records. Black holes are memory stars, ledger stars, horizon-bound accounting surfaces where selected reality and comparative anti-reality meet. Holography supplies the natural language. Boundary expectation selects bulk history. Light speed remains the local stitching rule. No signal outruns light, but the whole history is selected under global consistency by every loci of comparison. In this view, cosmology stops being the study of debris after an explosion and becomes the study of how quantum possibility, spacetime structure, and expectation select a universe large enough to remember itself. So number one, begin with the mistake. Expansion is not an explosion. No big boom. Most people hear universe expanding and they imagine an explosion, a cosmic grenade, a fireball expanding into darkness, galaxies racing outward like sparks from a blast. That picture is useful only if the goal is to misunderstand modern cosmology quickly and with confidence. Expansion is not matter flying through pre-existing space. Expansion is the evolution of the metric itself. The distance relation itself changes. Galaxies that are not gravitational bound to each other separate because the scale factor grows. A distant galaxy is not necessarily moving through space faster than light in the local sense. Rather, the intervening space-time relation is increasing from perspective. The ruler is changing. The geometry is growing. The stage is not sitting there while actors sprint across it. The stage itself is being written and increasing separation. That is the first pivot of this mathematics. The expansion is not motion in space. Expansion is the changing measure of space. Now Born-Hillborn asks a deeper question. What is that changing measure? What is the scale factor ontologically? Standard cosmology says the scale factor describes how cosmic distances grow. Correct. Born-Hillborn asks what growth means if reality is selected history. And that answer is expansion is selected history acquiring relational capacity. The universe expands because the history being selected must contain more than particles. It must contain records. It must contain horizons. It must contain entropy. It must contain stars. It must contain observers. It must contain memory. It must contain future consistent structure. The universe is not expanding into space. Space is expanding as the selected history gains room to remember itself. Space is expanding as the selected history gains room to remember itself. Expansion is memory room. Expansion is the widening of the cosmic record. Expansion is the growth of selected space-time history. That's cosmology, because the same process that stretches wavelengths, cools radiation, dilutes matter, and forms horizons also creates the possibility of records, observers, and memory. Materialism says matter expands, then memory accidentally appears in the meat. Born-Hillborn reverses that containment. History selection makes history and memories too big for brain-body. So Born-Hillborn reverses that containment. Memory is too large for brain-body. The brain is a local interface. Space-time is the larger selected record. The universe had to become large enough to remember us before brain could pretend it invented memory. 2. The Born-Hillborn rule in cosmological language. The Born-Hillborn rule is reality equals quantum mechanics multiplied by space-time expectations. Quantum mechanics gives us the possible histories. Space-time gives the consistency conditions. Expectation gives the weighting. Reality is the selected history. In ordinary quantum theory, a possible outcome has probability. In Born-Hillborn cosmology, a possible cosmic history also has a weight. We get the possibility from Born, and we also add the weight from expectations across space-time. That weight is not only past-driven, it is not only local, it is also from what we perceive of as the future. The block has a future that presently exists, from anyone that studies physics. So it is not merely a billiard ball chain of yesterday pushing today. The weighting includes space-time expectation. We bias the past that we expect, including and that includes future observers, future records, future memory, future horizons, future black holes, future questions, future measurements, and future coherence. It all matters to every decision. The universe is not selected as a single present frame. It is selected as a complete coherent history. A cat found alive in a box, cat in the box thought experiment, Schrödinger's cat cannot be just alive now. It must come with cat ancestries, cat metabolism, cat genes, cat parents, cat world. The present outcome requires a sporting history. Copenhagen sells us alive or dead like it is a clean little option package. But under the hood, that alive cat needs metabolism, memories, fur, parents, grandparents. And yesterday is breathing. The furniture needs scratch marks. The real paradox is not the cat, is the whole matching history, that magically comes with it. If the cat is created as definite only when observed, when we open the box, then its past must also be created too. You cannot drive off the lot with a live cat now unless the universe also hands you a live cat before. That is the hidden cost of Copenhagen on the macro level. They forgot to print in the Bohr-Heisenberg fine print. Get out those specs. Explain why the particle has a history, or what happened to the particle's history. The same applies cosmologically. A universe contains galaxies, carbon, observers, mathematics, grief, telescopes, memory, and questions about expansions cannot be selected as a bare present frame accident. It requires a supporting cosmic ancestry, a hot, dense, early state, recombination, primordial fluctuation, star formation, nucleosynthesis, black holes, planets, chemistry, biology, and the future measurements by which the past becomes stabilized as a record. So the Born-Hillborn cosmological version is the universe does not merely evolve from initial conditions. The selected universe includes the initial conditions required by its future consistent history. It does not deny the hot early universe, the hot dead state. It does not deny the cosmic microwave background. It does not deny nucleosynthesis. It does not deny expansion. It changes what those facts mean. They are not the debris of a mindless explosion. They are the early pages of selected cosmic memory. The Big Bang is boundary, not bomb. The phrase Big Bang is historically useful and metaphysically dangerous. It invites the image of a cosmic object exploding inside a larger emptiness. But there was no outside room, no pre-existing theater, no empty warehouse waiting for a galaxy. There was no room for it to explode inside. In modern cosmology, the Big Bang is the hot, dense state, early condition of the observable universe, not a normal explosion in space. So the Born-Hillborn cosmology goes further. The Big Bang is the low entropy boundary of selected history. Not a bomb, a boundary. Not matter appearing from nowhere, a compressed record seed. Not a chaotic firework, the first readable page of the comic book. The early universe is hot because its selected record is compressed. It is smooth because the later universe requires large-scale coherence. It has tiny fluctuations because stars and galaxies require seeds. It has low entropy because history requires an arrow. It cools because the selected record expands. That is the Born-Hillborn thesis. The Big Bang is the first public memory surface of the selected cosmos. Do not confuse earliest visible boundary with absolute metaphysical beginning. The beginning of the observable record is not necessarily the beginning of a reality. A photograph of a newborn is not the origin of the family. It is the first image in that album. Likewise, the hot early universe is the first recoverable album page of this selected space-time history. That is why the Big Bang should not be treated as proof that a dead universe invented itself from nothing and then accidentally became Bach. Black holes, biology, and Bayesian inference. A little humility around the word nothing would be refreshing. In Born-Hillborn cosmology, the early boundary is selected because the later history requires it. A universe with observers requires a past compatible with those observers that led to those observers. A universe with a memory requires a past compatible with memory. A universe with galaxies requires a past compatible with galaxies. The beginning is not arbitrary. The beginning is selected by every moment, every loci of comparison. The cosmic microwave background as memory page. The cosmic microwave background is often called the afterglow of the Big Bang. That is good, but Born-Hillborn gives a sharper name. The CMD is the first visible public memory page of the universe. It is the oldest light we can see directly. It comes from the time when the universe cooled enough for electrons and nuclei to form neutral atoms, allowing photons to travel freely. Before that, the universe was opaque. After that, light could carry a record. That is not merely an event, that is a transition in cosmic memory. The universe became transparent. The record became readable. The CMD is a fossil light field, a thermal signature, a boundary image, a cosmic baby photograph. And that's an important point. The baby photograph must match the adult. The present universe with galaxies, stars, elements, observers, and telescopes requires an early radiation field with the right structure. Not perfectly smooth, not wildly chaotic, smooth enough for coherence, uneven enough for structure. That is what we see. Nearly uniform, slightly anisotropic, mathematically rich, acoustic peaks, seeds of structure. A thermal record with just enough variation to let gravity begin writing galaxies. Standard cosmology says inflation begins the uniformity. Quantum fluctuation explains the seeds. Correct as an effective account. Born-Hillborn asks, what was the inflationary? fluctuation bearing structure seeding history that was selected? The answer: because future observer consistent history requires a CMD that can become galaxies, stars, heavy elements, planets, brains, telescopes, and memory-bearing beings capable of reading the CMD. Again, not a local signal from a future astronomers to early plasma. No little photons receiving a memo from graduate students. The whole history is selected under global consistency using the mathematics on your screen. The CMD is the early page that matches the later book. And yes, this is the cosmological equivalent of the cat having parents, of us having parents that aren't random, or pets that aren't random. One does not get an adult universe with telescopes unless the baby universe has the right photograph. 5. Cooling is the thermodynamics of memory room. The universe cools as it expands. That is the standard statement. Radiation redshifts, wavelengths stretch, photon energy decreases, the temperature of the CMD falls as the scale factor grows. Matter dilutes as volume increases. Radiation dilutes even faster because each photon also loses energy to redshift. Now, Born-Hillborn asks, what is cooling ontologically? The answer: cooling is the thermodynamic signature of expanding record space. The universe cools because selected history has more relational room. A hot early universe is compressed record potential. A cold late universe is expanded memory capacity. The redshift is not only a wavelength effect, it is handwriting of an enlarged cosmic record. As the universe expands, photons stretch into older memory. The CMD cools because the first public memory page is being carried through a growing metric. Temperature falls as the universe's history becomes less compressed. The refrigerator analogy is too crude. The library analogy is better. Imagine all the information in a city compressed into one small room. Heat, pressure, confusion, unreadability. Now expand the archive. More shelves, more separation, more record capacity, more structure, less compression. The universe is not just cooling, it's unpacking. It's taking stuff out of the boxes. It is becoming legible. That is the Born-Hillborn reading based on this mathematics. And it matters because memory is not a secondary accident. Memory is a structure of the selected history itself. The brain does not contain memory like a suitcase contains socks. The brain is an access interface to selected history, as is all of the cosmos. At cosmic scale, expansion is the increase of the very medium in which selected history can be recorded. That is why memory is too big for the brain body. Memory is cosmological before it is neurological. The brain is a local library card. It is not the library. 6. Inflation is rapid holographic registration. Inflation was introduced to solve several major problems. The horizon problem: why are distant regions of the CMD so similar if they could not have exchanged ordinary causal signals? And the flatness problem: why is the universe so close to spatial flatness? The monopole problem: why do we not see certain prediction relics? The structure problem: why do tiny quantum fluctuations become seeds for galaxies? Inflation is elegant, powerful, and somewhat suspicious, like a brilliant student who solves every exam question by introducing one private assumption nobody else saw. It may be correct as effective dynamics, but Born-Hillborn asks what inflation means. The answer is: inflation is rapid holographic registration. It is the early smoothing of the selected spacetime sheet. It is not merely an inflation field rolling down a potential. It is the early global synchronization of a universe that must later become coherent enough for us to understand it. The horizon problem dissolves in a new way using this math. The early universe did not need all regions to exchange local thermal gossip after the fact. The selected history is globally constrained. No faster than light signal, no photon breaking relativity, no secret cosmic email. The whole space-time history is selected coherently. This is a history selection model. Light speed remains the local stitching rule. We stitch the past and the future with every passing moment using this mathematics. Global selection is not local signaling. This is essential. A tapestry's final image constrains where each thread belongs, but no thread outruns the needle. A novel's ending constrains the first chapter, but no character sends a telegram backward in time. A solved Sudoku grid contains every square, but no number sprints across the page. That is the Born-Hillborn causality. Local signals obey light speed. Global histories obey selection consistency. Inflation is the standard model's way of describing early smoothing. Born-Hillborn is the deeper reason a smooth enough early sheet is selected. The universe must be coherent enough to form galaxies, stars, chemistry, observers, and records. The early smoothness is not a miracle. It is selected memory architecture. Flatness, the geometry of long memory. The universe appears very close to spatially flat on large scales. Inflation explains this by stretching curvature towards flatness. Born-Hillborn accepts that inflation may be the effective mechanism, but asks a deeper question: why flatness? The Born-Hillborn answer, based on this mathematics, is flatness is the geometry of long memory. Flatness in cosmology is nested observer dependent. The flatness problem asks why cosmic geometry sits so close to the critical balance, not closed enough to rapidly recollapse, not open enough to disperse structure before galaxies, stars, chemistry, and yes, observers like us can form. Standard inflation says early exponential expansion stretch curvature almost flat, like enlarging a tiny wrinkled patch until it appears smooth. Born-Hillborn accepts the mechanism, but adds the selected logic behind it. A universe with future observers must select a past geometry capable of sustaining long memory. Flatness is therefore not just lucky fine-tuning, it is the geometry of durable record space. A wild curved cosmos cannot keep enough stable history for stars, black holes, planets, brains, and cosmic measurement. It's following a cosmic plan. So in Born-Hillborn terms, flatness is selected because future consistent histories require a universe with enough geometric patience to remember itself. A universe too curved collapses too quickly, fragments too violently, or fails to sustain long-lived structure. A nearly flat universe permits extended causal stitching. It permits galaxies. It permits stars. It permits heavy elements. It permits planetary systems. It permits biological evolution. It permits observers. It permits memory. It permits cosmology. A universe with short memory cannot ask why it is flat. A universe with long memory can. That is not weak anthropic principle in passive form. The passive version says we observe a life-permitting universe because otherwise we would not be here. True, but that's thin. The Born-Hillborn mathematics says future observers' histories await the selection of the geometry that permits those observers, not merely we are lucky to be here. It's the history in which we exist is selected with the enabling geometry included. A cat expecting a bowl of milk could birth a universe. If there was nothing in existence but a cat that expected a bowl of milk, he would birth the cow, the farmer, the milk, the bowl, the potter, the ancestry, and a universe big enough to contain all of it. So we create the past needed to match our current now, so which is pretty blessed. So that is how this explains teleological cosmological selection. It's not a local future signal, it's a global history constraint. Flatness is therefore not just a number. Flatness is the architecture of extended memory. Flatness is patience built into geometry. Flatness is the universe giving itself enough room to become legible. 8. Dark energy as future-weighted expansion pressure. Now we reach the great modern embarrassment with excellent branding. Dark energy. The universe is not merely expanding, it is accelerating. Gravity should slow expansion, but late-time observations show acceleration, so standard cosmology introduces dark energy, a uniform component with negative pressure, often modeled as a cosmological constraint. Mathematically, it works well enough. Ontologically, it is a fog bank with equations. Born-Hillborn asks, what is dark energy doing? The answer, dark energy is future-weighted expansion pressure, or dark energy is expectation gradient expressed as geometry, or dark energy is the universe making room for the history selected from its future boundary. This is not a mysterious fluid first, it is selection pressure first. General relativity reads that selection pressure as geometry. The late universe accelerates because the selected horizon requires increasing horizon structure, record capacity, entropy distribution, and future consistent spacetime. A universe that will contain late observers, black hole memory, expanded horizons, and long thermodynamic records must have a geometry that opens accordingly. Dark energy is the name standard cosmology gives the opening. Born-Hillborn gives the reason. Future expectation weights the expansion profile. Again, no faster than the light signal. No galaxy receives a message from the future saying, please recede faster. No local law is broken. The whole history is selected with an expansion curve. Light speed is the local stitching rule. Global selection is the book-level coherence. This is why dark energy should not be treated as dumb repulsion. Things know where they're going. It is not just cosmic anti-gravity with the mysterious paycheck. It is the macroscopic pressure of selected future consistency. They are migrating like birds. And here Born-Hillborn becomes predictive. If dark energy is pure cosmological constant, it should behave with perfect featureless rigidity. If dark energy is expectation pressure, it should have history. It should be approximately smooth, but not metaphysically dead. It should show epoch dependence. It should correlate perhaps subtly with record formation, star formation, black hole entropy, horizon growth, galaxy formation, observed potential, and large-scale information structure. A universe with memory should leave memory-like fingerprints in the expansion curve. A constant says no story. Born-Hillborn says the expansion is the story. 9. Hubble's tension as a clue, not a clerical error. Now consider the Hubble tension. Early universe measurements interpreted through the standard lambda cold dark matter model infer one expansion rate. Late universe measurements using local distance ladders and supernovas infer a higher one. For years, the hope was simple. Find the systematic error, fix the calibration, correct the dust, refine the Cepheids, adjust the supernovae, blame the telescope, blame a pipeline, blame someone named Kevin. That may still be part of the story. Measurement systematics matter. Precision cosmology is not performed by vibes and decorative coherence. But if the tension persists across independent methods, it becomes more than nuisance. It becomes ontologically knocking. Born-Hillborn reframes the tension. Early probes read the compressed seed. Late probes read the expanded selected history. The early universe tells us what this seed allowed. The late universe tells us what the history became. If future expectation contributes to the selected metric, then a purely past-driven extrapolation may miss part of the expansion structure. The Hubble constant is then not merely a constant, it is a cross-section through selected history. The conflict is not necessarily somebody measured it wrong. It may be the model assumes dead expansion where the universe has expectation-weighted expansion. Standard cosmology asks, why do the early and late rulers disagree then? Born-Hillborn asks, why assume both rulers are measuring a universe with no expectation gradient? We have more math. This is the pivot. The Hubble tension becomes a possible signature that expansion history is being mismodeled as purely past-driven. That does not mean we throw away lambda cold dark matter. It means we stop treating it like stone tablets. A model can be brilliant and incomplete. Newton was brilliant and incomplete. Classical mechanics was brilliant and incomplete. Materialism is incomplete without the brilliant. Materialism is complete without the brilliant part. Born-Hillborn predicts that if Hubble tension is real, it should not vanish by better bookkeeping alone. It should leave structured residuals, environment redshift, voids, lensing, black hole density, and large-scale information measures may matter. Not random noise, history signature. 10. Dark matter is memory geometry. Dark matter is inferred from gravity. Galaxy rotation curves, gravitational lensing, galaxy clusters, the cosmic microwave background, large-scale structure, something gravitates more than luminous matter can explain. Standard cosmology says dark matter is likely a non-luminous matter component, perhaps particle-like, cold, weakly interacting, and gravitationally dominant. Born-Hillborn does not need to deny that, but it asks whether dark matter names a substance, a function, or both. In Born-Hillborn mathematics, cosmology, dark matter is unseen, history, selection, geometry, or memorably, dark matter is memory geometry without light. It is the gravitational shadow of the histories galaxies require in order to cohere. Galaxies are long memory structures. They are not just clouds of stars, they are rotating records of formation, merger, angular momentum, starbirth, black hole growth, chemical enrichment, and gravitational inheritance. The luminous galaxy is the visible sentence. Dark matter is the grammar holding it together. Standard cosmology looks for the hidden ink. Born-Hilborn mathematics asks whether some of that hidden ink is geometric memory. This does not abolish particle dark matter, it reframes the role. If dark matter is purely particulate, its distribution should follow particle physics and gravitational clustering. If dark matter also reflects some memory geometry, residual patterns should correlate with history variables, formation, age, black hole entropy, star formation record, merger history, environment, void proximity, and information density. That is a research program, not a bumper sticker. Dark matter is memory geometry, means test whether unseen gravity tracks not only mass but history. The same mistake appears again. Brains light up, therefore brain contains memory. Galaxies, curves, rotate. Therefore invisible particles alone contain the explanation. But maybe the local instrument is not the whole record. Maybe the visible object is embedded in larger memory field. The remote lights up. That does not mean the movie is inside the TV remote. The galaxy glows. That does not mean the whole gravitational history is inside the glowing matter. 11. Stars as history engines. What drive the now? Now we reach the stars. A star is not merely a ball of plasma. A star is a history engine. A star exports low entropy energy. The energy creates chemical disequilibrium. Chemical disequilibrium creates weather, metabolism, ecology, atmosphere, photosynthesis, food webs, eyes, nervous systems, memory, culture, and cosmology lecture rooms with suspiciously bad catering. The sun is not just shiny. The sun is writing history. Sunlight creates leaves. Leaves create oxygen. Oxygen creates animal metabolism. Metabolism creates movement. Movement creates nervous systems. Nervous systems create anticipation. Anticipation creates expectation. Expectation waits history. So the sun-born particulates participates in the Born-Hillborn chain. Quantum possibility becomes stellar energy. Stellar energy becomes local irreversibility. Local irreversibility becomes biological record. Biological record becomes memory. Memory becomes expectation. Expectation becomes history weight. This is not metaphor only. This is function. The sun makes futures possible. A planet without a star is potential without a pen. A planet without a star becomes a history-writing surface. This is why life is not accidental decoration. Life is how selected history becomes locally aware of itself. Stars are not background scenery. Stars are engines of record, rhythm, radiation, and remembering. The sun creates history, and if the sun is a history engine, then black holes are its opposite function. They're used for compare. They're not enemies, they're complements. Stars write, black holes audit. 12. Black holes as memory stars. The name black hole emphasizes absence, darkness, no escape, a cosmic drain. But black hole physics has already taught us to think in terms of information, entropy, horizons, and area. So Born-Hillborn gives a functional nickname, memory star. We like John Wheeler's teachings, but black hole it's better for our minds to focus on what it does. So memory star or ledger star, a black hole is not merely where matter disappears, it is where visible history becomes horizon-bound accounting. A black hole is a memory object, a surface of maximum entropy, a horizon record, an accounting boundary. In Born-Hilborn mathematics cosmology, black holes are comparative ledgers. They encode the gravitational memory of what has fallen beyond ordinary visibility. They preserve, compress, or account for selected histories and rejected alternatives. This is where the phrase anti-reality ledger enters carefully. Not anti-matter, not evil, not fantasy. Anti-reality as comparison. We need our minds need things to compare stuff against. Reality selects one experienced history, but the alternatives had to exist for us to compare. So selection implies alternatives. The selected path gains meaning against the space of what was not selected. The ledger records the comparison. Black holes are where the universe keeps the most extreme accounting surfaces. A star radiates, a black hole remembers. A star creates local futures, a black hole stores horizon past. A star gives structure to life, a black hole gives structure to entropy. A star is a flame of history, a black hole is a vault of comparison. The sun creates history, the black hole audits it. It binds thermodynamics, holography, gravity, information, and metaphysics into one image. And it sounds like cosmology finally noticed the universe has bookkeeping, which, frankly, black hole entropy has been shouting for decades. 13. The holographic universe. boundary expectation, bulk history. The universe should be described here as holographic, not because the universe is fake, not because matter is just illusion in the cheap sense, but because modern physics has already learned that boundaries can encode bulk. The black hole entropy suggests information scales with horizon area. That's wild. Holographic duality suggests that gravitational bulk can be equivalent to boundary information. The ADS-CFT gave the physics community permissions to take this seriously, provided the permission slip had enough symbols on it. Born-Hilborn generalizes the intuition. Boundary expectation selects bulk history. The bulk universe, galaxy, stars, observers, distances, radiation, matter. It is the experienced expression. The boundary, horizons, future constraints, information services, expectation structures, participates in selection. Expansion is then the bulk expression of boundary expectations. Dark energy is the pressure of that boundary expectation, opening spacetime. Black holes are local memory boundaries. The cosmic horizon is a global memory boundary. The CMD is an early boundary page. The future is not empty. It is a boundary condition of expectation that already exists. If you have a fast enough 1981 DeLorean. Now, the universe expands as its holographic memory boundary grows. The metric, the universe grows. The universe expands as its holographic memory boundary grows. Expansion is boundary expectation becoming bulk geometry. That is the Born-Hilborn holographic thesis. A three-dimensional world can be real as experience while still being encoded by deeper information structure. The image on a hologram is real as appearance. The information is deeper than appearance. Matter is not denied. Matter is resituated. Matter is the visible face of selected history. The deeper ontology is quantum possibility weighted by space-time expectation. The mathematics teaches what I'm saying. No signaling. Light speed is the stitching rule, from past to future, future to past. This model must not be misunderstood as faster than light signaling. It explains teleology and retrocausality in physics, but it's not faster than light signaling. Future expectation does not mean future text messages. It means future boundary conditions do not mean tomorrow sends a photon to yesterday. Teleology does not mean causality collapses into chaos. The speed of light remains the local stitching rule. It is the rule by which events communicate inside the selected history. This mathematics explains time. This selection math turns ever many worlds into the one world we know and love. No local observer can use Born-Hillborn expectation to send controllable information faster than light. No laboratory can telegraph superluminal messages. No galaxy receives a cosmic email from the future. That is not the claim of this mathematics. The claim is global selection. The whole history is selected under consistency constraints. Inside the history, light speed governs local causal communication. This distinction is everything. Local signaling is forbidden. Global consistency is allowed. A novel can have an ending that gives meaning to chapter 1, but the characters in chapter 1 did not receive a memo from the later chapter. A tapestry can have the final image that determined where each thread belongs, but no thread violates the entire image. The symphony can resolve a theme introduced early, but the violin note did not travel backward in time. Born-Hillborn is the causality. Local notes obey timing. The whole composition has structure. This is how FTL-looking effects become teleological without violating no signaling. Delayed choice experiments, advanced waves, horizon correlations, inflationary smoothing, dark energy acceleration. These are not invitations to throw away causality. They're invitations to upgrade causality, from local push-only causality to globally selected history across spacetime. The light speed constant is not abolished. It is honored. It is a stitching rule of the selected fabric. 15. Expansion and the arrow of time. Expansion and time are deeply linked. In standard cosmology, expansion gives an evolving thermodynamic background. Entropy increases, structures form, stars burn, black holes grow, radiation cools, records accumulate. Born-Hilborn makes this more exact. The arrow of time is the readable order of selected history. Time is not merely a parameter. Time is the order in which memory becomes stable. A cup breaks and the broken state contains more record than the unbroken state. A star burns and the burned fuel contains history. A fossil records biology. The CMB records recombination. A black hole records entropy. A brain records local access to selected past. But the brain is not the source of memory. The brain is an interface to the selected history itself. At cosmic scale, expansion allows the ledger to grow. Entropy is not simply disorder. Entropy is bookkeeping. Entropy is the cost of irreversible record. Entropy is the universe remembering that something happened. So the second law becomes selected history accumulates records. Cosmic expansion becomes the ledger space and that let record accumulation continue. The universe expands because the story needs pages to write on. Stars write sentences, black holes bind volumes, observers read and wait future chapters. That is cosmology with memory restored. And once memory is restored, the brain-body becomes local, not ultimate. The brain is biological index card inside a cosmic archive. 16. Replacing the Big Bang material myth. Now compress the replacement. The Big Bang is not denied, it is renamed in function. The hot, dense early universe remains. The CMB remains. Nucleosynthesis remains. Galaxy formation remains. Expansion remains. But the myth changes. The old myth, a dead universe exploded from nowhere, accidentally expanded, accidentally formed particles, accidentally this, accidentally that, accidentally formed stars, accidentally formed carbon, accidentally formed life, accidentally formed minds, and those accidentally minds now declare that mind is unreal. Born-Hillborn mythos, and here mythos means deep explanatory flame, not fiction, says quantum possibility and spacetime expectation. This math, selected coherent history. The earliest visible boundary is hot, dense, smooth, low entropy, and fluctuations seeded because the later universe required exactly such a past. The cat was expecting its bowl of milk, and so the bowl of milk is built into that state. Expansion increases relational memory space. Stars create local universe histories. Black holes preserve horizon ledgers. Observers emerge because selected histories become self-reading. Memory is not trapped in brains. Brains localize access to a selected record. The future does not send signals. The whole history is selected under global consistency. Light speed remains the local stitching rule. The universe is holographic, historical, and expectation weighted. That is a different cosmology. Not anti-science, more scientific. Because it explains why the parts fit. The past matches the present. The CMB matches galaxies. The expansion matches memory growth. The sun matches biology. The black hole matches entropy. The horizon matches holography. The future matches selection. Science is not materialism. Science is reducing paradox. Adapt or switch professions. Science is paradox reduction, not materialism. 17. Predictions. Where the model risks contact with data. A cosmological model must risk something. Otherwise, it is not a theory. It is a mood with vocabulary. Born-Hilborn cosmology should make predictions. What are they? First prediction. Dark energy should not be perfectly featureless forever. If dark energy is expectation pressure, then its effective behavior should vary with cosmic epoch. It may approximate a cosmological constant over broad intervals, but it should not be metaphysically dead. The second prediction, dark energy evolution should correlate with record formation. Look for relationships with star formation history, black hole mass density, entropy production, galaxy growth, horizon structure, and information measures. The third prediction, the Hubble tension should persist if it is not purely systematic. If late expansion is expectation weighted, early universe inference and late universe measurement should not reconcile perfectly on a purely past-driven model. Fourth prediction, expansion residuals should have structure. Void environments, superclusters, lensing past, black hole density, galaxy age, and large-scale information gradients may leave non-random fingerprints. The fifth prediction, black hole entropy density should matter cosmologically. If black holes are memory stars, their growth history should not be irrelevant to late-time expansion phenomenology. The sixth prediction, cosmic voids should be privileged laboratories. Voids are where matter is minimal and expansion geometry expansion geometry is cleanest. If dark energy is expectation geometry, voids may reveal where more clearly than crowded regions. 7th prediction. Standard sirens will become decisive. Gravitational wave distance measurements should test whether late-time expansion residuals follow electromagnetic ladders, lensing environments, or deeper metric history structure. 8th prediction. Redshift drift should reveal whether expansion is rigid or historical. Directly watching redshift change over time may distinguish the constant dark energy model from a selected history expansion curve. 9th prediction. CMB anomalies should be re-examined as boundary memory features. Large angle alignments, hemispherical asymmetries, low multipole anomalies, and other uncomfortable leftovers may be hints of global history selection, not statistical trash be swept under the cosmic rug. 10th prediction. Holographic boundary models should eventually outperform purely local fluid models. If expansion is boundary expectation becoming bulk geometry, a model with horizon, entropy, information, and future consistency terms should fit the full data better than a contextless constant. These are not small claims. This theory this is the mathematics. So, 18, the research program that we would need to develop Born-Hilborn cosmology. We need a research program with 3 levels. Level 1, we need reinterpretation, map standard cosmological quantities in a history selection language. The scale factor becomes selected history registration. Redshift becomes memory stretching. CMB temperature becomes early record cooling. Dark energy becomes expectation gradient geometry. Dark matter becomes memory geometry. Black holes become horizon ledgers. Level 2, phenomenology. Build effective terms that modify expansion of history without violating local relativity. Test time varying dark energy behavior. Test links between expansion of residuals and entropy production. Test environmental dependence. Test correlations with black hole mass density. Test void-specific expansion. Test redshift drift. Test standard siren measurements. Level 3, formal theory. Connect Born-Hilborn weighting to path integrals. 2 boundary quantum mechanics. Holographic entropy. Semi-classical gravity and quantum information. The formal ambition is clear. This mathematics is a selection model that resolves a lot of things. Even string theory needs a selector. So instead of summing possible particle histories with amplitude alone, sum possible cosmic histories with amplitude and expectation weight. Not as private psychology, as space-time expectation. That means observers are not late accidents. Observers are boundary-irrelevant systems. Memory is not a brain afterthought. Memory is the structure of selected history. This mathematics is consciousness. Black holes are not mere sinks. They are ledger boundaries. Dark energy is not mere vacuum mystery. It is the future expectation pressure in geometric form. This is where string theory becomes useful again. String theory's landscape problem asks, which vacuum? Which compactification? Which geometry? Which universe? Which landscape? Born-Hillborn answers, the selected history is weighted by future consistent expectation. The landscape is not merely a warehouse of possible universes. It is the possible space from which coherent observer histories are selected. ADS/CFT and holography are not ornamental mathematics. They are clues that boundary information and bulk geometry are 2 languages for one selection process. Born-Hilborn supplies the missing selector. 19. This is a guided walk through the whole Born-Hilborn cosmological model. This resolution to everything. At the earliest readable boundary, the selected history is hot, dense, smooth, low entropy, and fluctuation seeded. That is the Big Bang region, not a bomb, a boundary. Then rapid early registration smooths the cosmic sheet. That is inflation as effective dynamics, but Born-Hilborn as selected logic. Then the universe cools. Photons decouple. The CMB becomes the first visible public memory page. Then gravity amplifies small fluctuation. Dark matter or memory geometry scaffolds structure. Gas falls. Stars ignite. The sun and stars like it become history engines. They convert nuclear potential in a local irreversible record. They make chemistry, planets, life, perception, and memory possible. Black holes grow. They became ledger stars, memory stars, entropy anchors, comparative accounting surfaces. Galaxies evolve, heavy elements accumulate, biology emerges. brains form, but brains do not contain memory as little meat vaults. Brains localize access to selected history using this math. The universe becomes self-reading through observers, future records, future horizons, and future expectations weight the cosmic histories that contain them. Expectation accelerates as the selected history opens more space-time capacity. Dark energy is the geometric reading of that expectation pressure. The Hubble tension appears because early seed inference and late history measurement are not perfectly described by a dead past-only metric model. Cosmology becomes not the study of an explosion, but the study of a holographic history selecting enough room to remember itself. Boundary, expansion, memory, stars, black holes, observers. It's all future expectations, selecting history. Repeat. Expansion of selected history, acquiring memory room. Expansion of selected history, acquiring memory room. It's changing the metric. 20. Materialism as a small container problem. Materialism keeps making the same mistake. It mistakes the local inference for the whole source. It sees that the universe must have always been a box the whole time. It sees brain activity and says the brain contains memory. It sees luminous matter and says visible matter should explain galaxies. It sees local causality and says the future cannot constrain history. It sees the early universe and says the past alone must explain the present. It sees equations and forgets the equations appear in consciousness. The error is always containment. The brain contains memory. Matter contains mind. The past contains the future. The local contains global. The visible contains the real. This is our sarcasm. Born-Hillborn reverses that. Memory contains the brain as an interface. Mind-like selected the history contains matter as appearance. The whole history contains past and future as jointly stitched boundaries. The global selection contains local causality. The visible is a subset of the real. This is why the remote control analogy matters. The remote control may light up when you activate it, but it doesn't mean that a brain or a remote control store movies because they light up when they're activated. It doesn't mean that the movie is inside the remote. The brain lights up when the memory is accessed. That does not mean the life history is inside the brain. The galaxy glows where stars exist. That does not mean the whole gravitational memory of the galaxy is inside luminous matter. The CMB glows as early radiation. That does not mean the universe is merely the debris of blind explosion. The instrument is not the source. The interface is not the archive. The glowing part is not the whole history. That is the elegance of this model. It fixes the scale error. 21. The final integration. What expansion is exactly. So what is expansion exactly according to Born-Hillborn? Expansion is the increase of relational space-time capacity in the selected cosmic history. It is measured by the scale factor. It is observed through redshift. It cools the CMB. It dilutes matter. It stretches radiation. It opens horizons. It permits entropy growth. It permits stars to write local history. It permits black holes to store horizon memory. It permits galaxies to develop. It permits chemistry to complexify. It permits observers to emerge. It permits memory to become local through brains access. It permits future expectation to participate in selection. It is not an explosion. It is not empty swelling. It is not meaningless metric drift. It is the universe becoming large enough to contain the history it is selected to do. And since selected history includes future observers, expansion is teleological without violating relativity. No signaling outruns light. No galaxies receive a command. No local law is broken. Light speed remains the stitching rule. But the whole space-time history is selected under global expectation. That is how future can matter without faster-than-light messaging. That is how cosmology can be teleological without becoming childish. That is how dark energy can be expectation pressure without becoming magic. That is how memory can be cosmic without insulting neuroscience. That is how black holes can be memory stars without denying general relativity. That is how string theory can find its selector. That is how quantum mechanics can become cosmology. The universe has holographic memory. The universe is not expanding in space. Space is expanding as selected history gains record capacity. The CMB is not merely afterglow, it is the first visible memory page. Inflation is not merely a convenient patch, it is a rapid holographic registration. Flatness is not merely fine-tuning, it is the geometry of long memory. Dark matter is not merely invisible stuff, it is, at least functionally, memory geometry. Dark matter is not merely repulsive mystery, it is future-weighted expectation pressure. Black holes are not merely cosmic drains, they are memory stars, ledger stars, horizon-bound accounting services. The sun is not merely a furnace, it is a history engine, it's creating our moments. The brain is not a meat vault, it is an interface to selected history. Memory is too large for the brain body because memory is not a thing hidden in tissue. Memory is the access structure of selected history, and expansion is the cosmic version of that same principle. The universe expands because selected history needs room for its records. It needs room for radiation to cool, rooms for stars to burn, rooms for galaxies to rotate, rooms for black holes to remember, rooms for observers to arise, rooms for mathematics to one day be discovered, room for the future to await the past, room for reality to become readable. The materialist story says the dead universe accidentally expanded, accidentally made minds, and those minds accidentally decided mind is not fundamental. The Born-Hillborn mathematics says quantum possibility, space-time structure, and expectations select a universe whose expansion is the growth of a holographic memory. Science is not materialism, science is paradox reduction, and the expansion of the universe is not the universe running away from itself, it is the universe making room to remember what it is. If you're a scientist, learn this math.